Large public clouds like AWS are worth over $500 billion. But using them is like pulling teeth. Businesses are forced to spend billions of dollars in engineering salaries just to manage servers on AWS. I saw this firsthand at Stripe, where I was employee number 8, and I helped launch the company and grow it to a $5 billion valuation, but not without a massive DevOps team. After Stripe, I built a lot of my own apps to figure out what I wanted to do next. Building these apps was easy, but hosting them was agonizing. I had to spin up VMs, install dependencies, set up networking, SSL, load balancers, just a ton of things for every single app. It was tedious, it was error-prone, and it needed to stop. This is how Render was born. Render is a completely automated cloud provider. You can use it to host anything, from a simple static website to complex application clusters. And you can do it faster than on any other cloud and without managing servers at all. Render fits into your existing workflow. Simply push your code to Git. We automate everything from there. This includes building and deploying your code, securing and updating the underlying software, scaling your apps, and automatically load balancing between them, and finally alerting you to potential problems. I realize I'm making a bold claim, so let's see this in action. You may have heard of Mattermost. It's like Slack, but for companies who want to host chat themselves. Typically, Mattermost requires a whole team of DevOps engineers to set up and manage, but Render makes this effortless. All I need to do is to click the Deploy to Render button in this GitHub repo. It brings me to my Render dashboard, listing all the services it's going to deploy. I click Approve, and that's it. Render is now deploying my Mattermost cluster, which includes a database, object storage, a search engine, and multiple web servers. Render is also provisioning load balancers and SSL behind the scenes, and I don't have to lift a finger for any of it. Now, these services can take a few minutes to spin up, so we're going to switch to an existing Mattermost instance running on Render. It's up at rendermost.com, and you can all go there right now and sign up. It's ready to scale to thousands of users. Let's talk about what we just saw. Installing Mattermost on Render requires just minutes, but it takes days of setup and constant ongoing maintenance on AWS. And it isn't even possible to do this on something like Heroku. But Render makes it instant through 3 major innovations. 1, every Render service gets built-in private networking, service discovery, and load balancing. 2, Render is the first fully managed cloud to offer SSDs with automatic backups and one-click restores. And 3, Render lets you define all your services in just one file. You can update your infrastructure by simply pushing this file to Git. How cool is that? Now let's look at the competition. Clouds like AWS claim to be developer-friendly, but any developer will tell you just how frustrating they can be. On the other hand, managed clouds like Heroku have stagnated under Salesforce and are missing essential features like SSDs and private networking. They're also much more expensive. Just 2 gigabytes of RAM costs $250 a month on Heroku versus $25 a month on Render. We truly give you the best of both worlds. Incredible ease of use combined with tremendous flexibility. And we're doing it in a market that is massive and growing quickly. Right now, we're focused on the platform as a service market, worth $20 billion. Longer term, we're looking at the entire cloud infrastructure as a service market, estimated at $100 billion just 3 years from now. But let's talk real numbers. Render's revenue has grown by over 50% month over month for the last 6 months straight. And this growth has been entirely organic. Our platform is now serving over 100 million HTTP requests every week. Leading open source projects like React, Vue, and Gatsby have all selected Render as an official hosting option. And we're also one of just 4 official cloud partners for GitLab. We have thousands of amazing users, including a leading presidential campaign that moved all their infrastructure over from GCP to Render recently. So, if you're a developer or founder who's frustrated with AWS or Heroku, and you're looking to save big on time and engineering costs, automate your cloud hosting today by signing up on render.com. Thank you.
Judges?
Can you describe as succinctly as possible the IP-protected components of your system?
There is a lot of work that we've done to build scalable, distributed proxies and routers on top of underlying virtual machines. There's also a lot of work we do in terms of bundling application code automatically into containers, which is all IP protected as well. And finally, there's a bunch of behind-the-scenes work to make sure everything is up and running at all times. So even if our database goes down, for example, our user websites are still going to be functional.
What's your underlying infrastructure?
Right now, we're using both GCP and AWS. Longer term, we're most likely going to switch to our own bare metal clusters.
Can you talk a little bit about the trade-off between ease and performance? Because while it might be easy for it to overall be managed, one of the reasons a lot of teams choose to do this type of load balancing, parallelizing, all the different things that you might do in a public cloud for yourself, it helps you actually get a more performant application. So what kinds of trade-offs do you see people making as they move from, say, AWS to Render in terms of speed of application and just how efficient and optimal the code is?
Sure. I don't think that there is a dichotomy between this in terms of how we've implemented it. So for example, when you talk about load balancing, we have built our own Layer 4 TCP load balancer that is as performant as any other load balancer on AWS or GCP. And our backend is written in one of the most highly scalable languages, like specifically Go. And we're making sure that the extra overhead that Render adds is always less than 10 milliseconds or less than 5 milliseconds per request. And then behind the scenes, I mean, the load balancing itself doesn't really add any additional performance issues.
Yes, I understand that. I think that I guess what I'm really getting at is you can do all that without knowing what the underlying tasks are. Because sometimes the tasks themselves defines whether or not something can be done in parallel or whether or not it can be balanced a particular way.
Yeah, so we allow our users the flexibility to define whether they want to scale vertically or horizontally, and we make that really easy. So if you know that your application is going to take 4 gigabytes of RAM, then you can select that plan on Render. And if you know that your application requires 3 instances that take 1 gigabytes of RAM each, then you can also do that on Render.
Do you see yourself as a 4th cloud provider eventually? And if so, what sets of applications or what sets of developers are you targeting that will not be launching their applications on AWS, GCP, Azure?
We're targeting startups and individual developers and consulting agencies and companies that do not or cannot hire DevOps engineers. DevOps engineers are some of the most expensive engineers to hire today, and they're also just really hard to find. And what we're doing is taking that need away and making sure that we're automating everything that you would need a DevOps engineer or consultant for. And so if we do become sort of this 4th cloud provider that you're talking about, we're not really directly competing with AWS or GCP. We're actually running workloads on all of these clouds. So as an example, if someone wants to say, hey, I want to run this workload on both AWS and GCP, and I want them in 2 different regions, you'll be able to do that with a single click on render. Whereas AWS is never going to allow that.
I'm trying to think of the trade-offs here between power and ease of use, and it seems like there's not, and you're a bit of everything for everyone. What's it not good for?
What it's not good for right now, it's not good for example, GPU-based workloads. So we don't support that right now. Deep learning is something that I think, so I've built and sold a company that actually ran deep GPU-based workloads, but it's something that we want to do in a much more measured way this time. So right now we're focused on.
But you could build that. It seems like that even that you can build with all the necessary infrastructure underlying from Amazon.
Sure,
and
yeah,
Google.
we can build it, but right now people don't have the ability to do that on render. Longer term, when you think about workloads that require a very specific kind of hardware, or maybe they require access to a VM in a way that I'm trying to come up with ways, but given containers where you can package all the applications up along with your dependencies, it's just not easy for me to think of applications that won't be able to work on render.
Okay.
Yeah.
Write your obituary.
Say it again?
Your obituary.
Yeah.
If 2 years from now your company failed,
Yeah.
why did it fail? Like what didn't go right, or what did you expect would happen that didn't?
I'd say it might fail if we lose one or more people on our team, like literally obituaries for them. But but I think that we'll fail if we lose sight of what developers want. And that is something that we have to be very careful about. And I used to work at Stripe and made sure that we were always working to please developers. Now, as we grow, if it's hard for me to scale out that culture, that's something I'm very conscious of, and making sure that, otherwise nothing differentiates us from AWS. They don't care about developers, we do, and we understand them much better than anyone else does. And then if we fail, I think it's going to be because we lost sight of that.
Platform as a service is something that people have talked about for over 10 years. Yeah. And I'm just wondering, what is it about the market today that makes render uniquely possible?
Yeah. So I think the biggest two things that have made this possible are the rise of container orchestration, Kubernetes, and obviously application packaging like Docker. Now, these are the two technologies that have only now become really viable and have been deployed at scale. And there's a lot of ancillary infrastructure built around them to manage all of this at scale. So that's why render is possible now. Whereas, back in 2010 when Heroku launched, they had to build all of this from scratch, and they still have this thing called dynos, which is like a poor man's version of a Docker container.
Final questions? All right, give it up for Render.